Hello everyone, section 9.7, law of sines and law of cosines. We're going to start off by finding each of these values using a calculator. So what happens in this unit is we've discovered that we can take sine, cosine, and tangents of angles that aren't in triangles. They are not found in right triangles. In fact, this whole unit is about non-right triangles. And how we can use law of sines and law of cosines to find the missing sides and angle values. So we're going to use a calculator here to find tangent of 92 degrees rounded to 4 decimal places. So tan 92 gives me negative 28.6363. Rounds up to a 3 at the end. Sine of 175 degrees. And sine gives me 0.0872. And cosine of 149 degrees. Cosine 149, negative 0.8572. Okay, so noticing, in sections 9.4, 9.5, 9.6, all of our sine, cosine, and tangent ratios were just that. They were all ratios, and they were ratios from right triangles. So they were all positive. What we're seeing here is that their values don't have to be positive. They can be negative. They can be more than 1 in the case of tangent. They can't be for sine and cosine, or less than negative 1 in the case of sine and cosine. Tangent, they can take on just about any values. When you take trig and precalculus, you'll find what values tangent cannot take on. We also see in this unit that there is another way to find the area of a triangle, 1/2 AB sine C. So, and we use this if the given information is side angle side information. So if we know little a, we know little b. Little a is always opposite big A, little b is always opposite big B, so on and so forth. If we know little a, the length of side BC, and if we know little b, the length of side AC, and we know the angle C, measure of angle C, side angle side, then we can find the area of this triangle using this formula right here. It's very convenient. Find the area of the triangle rounded to the nearest tenth. So notice we have side, angle, side here. So we have area of the triangle is equal to 1/2 12 times 15 times the sine of 110 degrees. Half of 12 is 6. 6 times 15, because it's 90. Sine 110 degrees. And 90 times sine of 110 gives us 84, rounded to the nearest tenth, 84.6 units squared. Example 2. Example 3. Our first time using the law of sines. Okay, law of sines is the easier of the two. It's a nice simple ratio. Sine of A over sine of big A over little a equals sine of big B over little b equals sine of big C over little c, or little a over sine of angle A, you can do the reciprocals of all of them, is going to equal little b over sine of angle C, or little b over sine of angle B, or little c over sine of angle C. So we're going to solve this triangle, round to the answer to the nearest tenth. So we have one ratio that we can write already. We have a 36 and a 70, which are opposite each other. So we know one ratio completely. So we're going to use that. So we're going to use the fact that we know sine of 70 degrees over 36. That's one complete ratio. If we have one complete ratio, then we can solve this. Equals, we're missing angle R, we're missing angle P, we're missing side P. We know 18. 18 is opposite the R, so that's the one, because that's the information that we know. So this is the angle that we're going to go for. So sine of R, angle R, over 18. This is solvable. We can solve this problem. Okay, a little cross multiplying. Sine angle R equals 18 sine 70 degrees over 36. 18 and 36 reduce. Sine angle R equals sine 70 degrees over 2. Okay, I don't want to know sine of angle R, I want to know angle R. Let me back up here. This word solve, solve the triangle. That means find all the missing sides and all the missing angles. We're finding our first missing angle, then we're going to find this angle, then we'll find this side in the end. Those are the three things that are missing in this problem. So I don't want to know sine of angle R, I want to know angle R. So to know that, we need to do inverse sine, or sine inverse of both sides. So now I have angle R equals sine inverse, or inverse sine, sine 70 degrees over 2. And typing that into the calculator might be a little confusing. You're going to have to practice how you use your calculator. Different calculators work differently. We talked about this back in section 949596. You need to know how your calculator works, and you need to know the order in which you push the buttons. So my calculator is going to work differently from somebody else's calculator oftentimes. And we're going to round this answer to the nearest tenth when we get this. So 70 sine divided by 2 equals 0.46984, so on and so forth. And we're going to do inverse sine of that. Find the angles. Measure of angle R is equal to 28.0 degrees. This is 28.0 degrees. Now, you might be saying, well, we don't know either of the P, so we can't set up a ratio to find angle P or to find side length P or RQ. But we can't forget that this is still a triangle, and all three angles still have to add up to 180 degrees. So triangle angle sum applies. 28 plus 70. Subtract that from 180. And I get angle P is 82.0 degrees. So the measure of angle P equals 82.0 degrees. We still have to find little p, but we know angle P now, so we can set up a ratio again. We're going to go back and use sine of 70 and the 36. So little p over sine of angle P, which is 82.0. I'm just going to write 82, equals 36 over sine of 70. Hopefully you noticed I flipped the ratios upside down. I like to have what I'm solving for in the numerator. it really doesn't matter. The algebra is still going to be the same. I think the algebra is just a little bit easier if I leave my what I'm solving for in the numerator, but it's not required. So little p equals 36, I'm multiplying both sides by sine of 82, 36 sine of 82 degrees over sine of 70 degrees. P approximately equal to 36 times 82, oops, wrong button, 82 sine divided by 70 sine equals 37.9 units. We don't have unit measurements here. So we have found angle R, angle P, and side P, or side RQ. That was example 3. Example 4. Again, solve the triangle. And that's what we're going to be doing throughout all of these. And when we can use law of sines, this one tells us we can, we're going to because it's easier. So again, I know this 25 and I know what's opposite it, the 38 degrees. Whenever I know one complete ratio, we're using law of sines. Okay? Because we know the 115, we're going to find C first. So we've got little c over sine 115 degrees equals little a, which is 25, over sine of angle A, which is sine of 38 degrees. Multiply both sides by sine of 115. C equals 35 sine 115 degrees over sine of 38 degrees. Again, rounding to the nearest tenth. Little c is equal to 115 sine times 35 divided by sine of 38. It equals, and I've got approximately 51.5 for my value of C units. 51.5. So now we want to find angle B and little b. Now, angle B I could have found right away because triangle angle sum theorem. 180 minus 115 minus 38, 27 degrees. Measure of angle B equals 27 degrees. And we're going to use that 27 with the little b. And again, I'm going to go back to the 25 and the 38 instead of using a rounded number of 51.5 and the 115. I'm going to use the ratio that was given. So we're going to go little b over sine of angle B, or sine of 27 degrees, equals little a, which is 25, over sine of angle A, which is sine of 38 degrees. Solve for the little b, multiply both sides by sine of 27 degrees. Little b equals 25 sine, oh, I just found a typo. And I'm going to come back. This should be a 25. I don't know how I copied that. All of a sudden it made it a 35. And that's going to change this number here. It's not going to change our value for b, luckily. So I'll go back and correct that in a second, as soon as I finish finding little b. So 25 sine 27 degrees over sine of 38 degrees. Go to our calculators. 25 times sine of 27 divided by sine of 38 and this equals 18.4 units. Go back and fix this one. So now it says I wrote 35 again after I erased it. 25. Okay. 25 times sine of 115 divided by sine of 38 equals 36.8. Okay. So little c is 36.8 units, little b is 18.4 units, and the measure of angle B is 27 degrees. And there's example 4 fixed now. Example 5. Surveyor makes measurements shown to determine the length of F of a walking bridge to be built across the pond in City Park. Find the length of the bridge to the nearest tenth. So in other words, find the length of segment DE, or we just want to find the little f. Okay. Now, we currently don't have one complete ratio. We don't have f because that's what we're looking for, but we know angle f. We don't know little e, but we know angle E. We know the 45, but we don't know angle D, or do we? Triangle angle sum, 180, minus 65, minus 79, equals 36 degrees. And now we have our complete ratio, 45 and sine of 36. So, little f over sine of angle F, which is 79 degrees, equals little d, which is 45 feet, over sine of angle D, which is sine of 36 degrees. Solve for f by multiplying both sides by sine of 79. F is equal to 45 sine 79 degrees over sine 36 degrees. What I hope you've noticed is I'm not doing a sine of 79 degrees and writing down a decimal to the nearest tenth. I'm not doing the sine of 36 degrees and writing that decimal down to the nearest tenth or even to the nearest hundredth, and then plugging those rounded numbers into my calculator. What I'm doing is I'm plugging all of these in as they are and rounding one time at the very end of the problem. I don't want to be rounding multiple steps during the problem. So f is approximately 48 times sine of 79 degrees divided by sine of 36 degrees, which is 80.2 feet. So the bridge across this water is going to be approximately 80.2 feet. Law of cosines. So law of cosines is more complicated. It's a little bit harder to use to type into the calculator. It's not harder to plug in to the formula, but sometimes it's a little harder to type it into the calculator. It's not overly complicated, but some students can get a little bit confused with it. There are 3 versions of it. All 3 are exactly the same. It all depends on what it is that you're trying to find or what angle it is that you're given. For example, here we're given angle C, or what you're trying to find. If you're trying to find angle A, or if you're trying to find angle B, there are 3 versions of it. I will just give you the sine, C squared equals A squared plus B squared minus 2AB cosine C. Okay. There's also B squared equals A squared plus C squared minus 2AC cosine of angle B. In all the cases, what you're taking the cosine of is what's on the other side of the equal sign. What's multiplied times the cosine are the two that aren't on the other side, that are on this side of the equal sign, same side of the equal sign. So in whatever version you use, the setup's still the same every time. Okay, so we're going to solve this triangle. Now, before I go any further, I'm going to jump ahead to this page. Okay, and I didn't show you this page before because when we were doing law of sines, it wasn't that important. In fact, it's not important when we're doing law of sines, but when we're doing law of cosines, this page really comes into play. Okay, so if we are given angle, angle, side, or angle, side, angle, then we're going to use law of sines, triangle, angle, sum theorem, and then law of sines to find the missing. So triangle, angle, sum theorem to find the missing angle, and law of sines to find the remaining sides. When we're given, and we'll come back to this one, side, side, angle. We're going to come back to that one, because that one, we're going to start with law of sines on that one, but that's called the ambiguous case of the law of sines. And I told you back in chapter 5 when we were first introduced to side, side, angle, the donkey theorem, that it doesn't work. It's not enough information to prove the triangle is congruent, and that is correct. But I also told you back in chapter 5 that you're going to see this again when you take trig and pre-calculus, and they're not going to call it the donkey theorem, they're going to call it the ambiguous case of the law of sines, which it is. It doesn't mean that that you can't prove the two triangles congruent. Well, you can't. It does mean you can't prove the two triangles congruent, but it doesn't mean that they don't exist. It's possible that there are two triangles with this information that are exactly the same. It's possible there are two triangles with this information that are not the same. And it's possible that there are no triangles with this information, that no triangle exists at all with this information. And when you take trig and pre-calculus, you're going to study all three of those different cases, all three of the possibilities. I do have examples in this unit that I'm going to show you that take you through the different possibilities of side-side angle, but you are not required to solve side-side angle. You are not required to know the different cases. That's for the future. So I'm just exposing you to it in this unit. You do not need to know it for certain. But what you do need to know are cases 3 and 4. Cases where we have side, angle, side, and side, side, side. When we have side, angle, side, or side, 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 we have to start with the law of cosines. Let me show you why. Back here in example 6, why do we have to start with the law of cosines? So here, I'm telling you it's side, angle, side, and then we got to start with law of cosines. I'm not going to tell you that on a quiz or a test, but this is just the first time seeing it. So we have side, angle, side. We have 40 degrees. We don't know angle C. So we know capital C. We don't know little c. We know little a. We don't know capital A. We know little b. We don't know capital B. We can't find capital A or capital B using triangle angle sum theorem. We cannot create one complete ratio. We can't do sine of angle A over little a. We don't have a sine of angle B over little b, and we don't have a sine of angle C over little c. We don't have one complete ratio. We can't use law of sines. We have to use law of cosines first. Okay? Back to the chart. How we proceed is important. If it's side, angle, side, or if it's side, 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 we're going to proceed differently. Okay? So in side, angle, side, you're going to find the third side first. Okay, so step 1, you're going to find the third side first. After you've found the third side, using law of cosines, you're not going to use law of cosines again. You're only going to use law of cosines one time in the problem. We're going to use law of sines every other time after that because law of sines is easier. So after you found the third side using law of cosines, using law of sines, you have to go after the smaller of the two remaining angles. Okay, now how are you going to know which one is the smaller of the two remaining angles? Well, we're going to find little c. After we find little c, we have to find angle A and angle B. How do I know which one is the one that I have to go for first? I have to go for the smaller of the two. And how do I know which one the smaller of the two is? The smaller one is opposite the smaller side. So 20 is smaller than 25. So angle A is the smaller angle. That's the one that you have to go for, we have to go for first after we find little c. So the order in which we're going to do this problem is going to be little c, capital A, and then using triangle angle sum theorem, we'll find capital B. Okay? That rule is going to be true when you take trig and pre-calculus as well. That rule is not made up by me. That's going to be true for trig and pre-calculus as well. And when you take trig and pre-calculus, you're going to know why, because cosine has more than one value, same with sines. Okay? Different rule if we are given side, side, side. If we start with side, 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 then you have to find the largest angle first. And again, how do we know which angle is the largest angle? You're going to know it by, do I have a side, side, side example here? I do. It's going to be the next one we do. Side, side, side example, we're going to know which angle is the largest angle because it is opposite the largest side. So when we get to example 7, we're going to find angle A first. Once we find angle A, longest side, example 2, we can find either of the remaining angles using the Laurent signs. It doesn't matter at that point. Okay, once we have found the largest angle, and that's the key, then we can find either of the two remaining angles using Laurent signs. Okay, so I'm going to refer back to this a few times if we need to, every time we're doing a new problem. But these two cases are the ones that you have to concern yourselves with in this unit. Case number 2, you don't have to worry about until you take trig and pre-calculus. And case number 1 is very simple. There's no restrictions. It's just using triangle angle sum theorem and the law of sines. Okay? All right, back to example 6. So example 6, using the law of cosines and side angle sine case, we're going to solve this triangle. We're going to find all the missing information. Okay, this is side angle side. So what did we say we were going to find first? Because it's side angle side, we find the missing side first using law of cosines. So we're going to find, since we're finding c squared, we're going to use c squared equals a squared plus b squared minus 2ab cosine c. So c squared equals a squared plus b squared minus 2ab cosine c. C squared equals a squared, 20 squared, plus b squared, 25 squared, minus 2 times 20 times 25 times cosine of angle C, cosine of 40 degrees. C squared equals 400 plus 625 minus 40 times 25. 4 times 25 is 100. 1,000 cosine 40 degrees. Now, one of the common mistakes is to go 400 plus 625 minus 1,000, right? So this is going to be 1,025 minus 1,000. So people will write 25 cosine of 40 degrees. That is a mistake. Don't do that. Why? Order of operations, PEMDAS. There's multiplication between the 1,000 and the cosine. That has to be done before you can do the subtraction. I can do this addition out here, but I cannot subtract 1,000 from the 1,025 before I multiply by cosine. So we can't do that. Another mistake is to forget to square root. So C is equal to square root 1,025 minus 1000 cosine 40 degrees. Okay, cosine approximately equal to, and we're going to round this to the nearest tenth. So again, you're going to have to practice with your calculators entering this in correctly and knowing how your calculator works. So cosine of 40 times 1000. And I have to subtract that number from 1025. I've got a number that looks like 258.955568, okay? And I'm going to square root that. And I get C is approximately equal to 16.1. If you don't have 16.1 units, then you entered something into your calculator incorrectly, and you need to practice with your calculator more. Okay? So now that I know C is 16.1, let's remember back to what that chart said. Side angle side, after we find the third side, you have to find the smaller of the two remaining angles using law of sines. So we're going to find the smaller of the two remaining angles, which we know is angle A, because it's opposite the 20. So smaller than the 25, angle B. So we're going to do sine of angle A over 20 equals sine. I now have a complete ratio, 40 degrees over 16.1. Okay, now when you take trig and precalculus, they're not going to let you use a rounded number here. I'm letting you use the rounded number here. Okay, let's multiply both sides by 20. Sine angle A equals 20 sine 40 degrees over 16.1. And I got to do inverse sine of both sides, or sine inverse. Measure of angle A equals inverse sine or sine inverse 20 sine 40 degrees over 16.1 and approximately equal to, go to our calculators, 40 sine of 40 degrees times 20 divided by 16.1 equal to like 0.79849, so on and so forth. I got to now do the inverse sine of this number, and I get 53.0 degrees. If this is 53 degrees and this is 40 degrees, 53.0 degrees gives me measure of angle B. Last piece of information that I needed is 87.0 degrees. And that is all of example 6. Example 7, again, law of cosines, but this time it's side, side, side. Let's take a look at our chart, refresh our memories. Side, side, side. We have to find the largest angle first, and then after that it doesn't matter. So, I told you earlier, for example 7, the largest angle is angle A. So that's what we're going to find, which means we're going to do a cosine of A, find angle A. So we're going to do A squared equals B squared plus C squared minus 2BC. again, I started with a squared because I'm looking for angle A. The only law of cosines that has an angle A in it is this version. BC, so A, BC, BC on the right, cosine of angle A. Let's plug in what we know. 30 squared equals 27 squared plus 18 squared minus 2 times 27 times 18 cosine angle A. Squeeze that cosine angle A in there. So 900 equals 27 squared, 729 plus 18 squared, 324 minus 2 times 27 times 18, 972 cosine angle A. Again, I can add these together, but do not subtract the 972. Okay. In fact, I'm going to subtract 729 and 324 from the 900. 900 minus 729 minus 324 equals negative 153 equals negative 972 cosine of angle A. I'm going to divide both sides by negative 972, so I now have cosine angle A equals positive 153 over positive 972. I want to know what angle A is. Inverse cosine, cosine inverse, both sides. Cosines cancel on the left. Measure of angle A equals 153 divided by 972 gets me a number, and I got to do inverse cosine of that, and I get approximately, and again we're rounding to the nearest tenth, 80.9 degrees. Measure of angle A here, 80.9 degrees. Okay? Now, according to the chart, we can find either B or C next. It doesn't matter using law of sines. Go after B. So sine angle B over little b, which is 27, equals, I now have a complete ratio, sine of angle A, which is, we just found 80.9 degrees. And again, I'm going to allow you to use this rounded number, trig and precalculus, they won't, over 30. Multiply both sides by 27. Sine angle B equals 27 sine 80.9 over 30. And we want to do inverse sine of both sides. Measure of angle B equals, we'll go to our calculators, 27 times 80.9, oops, 80.9 sine divided by 30 equals, I get 0.888724, so on and so forth. And I got to do the inverse sine of that, and I get approximately equal to 62.7 degrees. Triangle angle sum theorem is going to get me angle C. So 180 minus 80.9 minus 62.7 gets me measure of angle C equals 36.4 degrees. And we have found all three of the missing angles for example 7. All right, example 8. Use a calculator and type in cosine of 90. So 90 cosine 90 degrees equals, when you hit cosine of 90 degrees on your calculator, you should come up with 0. Okay? Example 9. That's going to lead us into this example 9 here. Using the result from example 8, simplify the third form of the law of cosines, where we have c squared equals a squared plus b squared minus 2bc sine of angle, 2ab sine of angle c. So c squared equals a squared plus b squared minus 2ab cosine angle c. Angle C is 90 degrees. Okay, so we're just simplifying things if angle C is 90 degrees. C squared equals a squared plus b squared minus 2ab cosine of 90 degrees. Just found in example 8, cosine of 90 degrees is 0. So this is 0. C squared equals a squared plus b squared minus 2ab times 0. What's anything times 0? 2ab times 0 is gone. What are we left with? C squared equals a squared plus b squared. Does this look familiar? It should. Let's think back. If angle C is 90 degrees, what type of a triangle is this? This is a right triangle. What you've just seen is a proof that the Pythagorean theorem is just a special case of the law of cosines when we have a right angle. The Pythagorean theorem is a special case of the law of cosines when the angle that we're working with is a right angle, when we have a right triangle. The Pythagorean theorem is going to work. Now, nobody shows you this first because we're not going to show you the law of cosines in middle school. We could show you the Pythagorean theorem and just work it for right triangles. Well, what the truth is the law of cosines works for any triangle, whether it's right or not. If it is a right triangle, then the formula is simplified a little bit to the Pythagorean theorem. That is example 7. I'm sorry, that was example 9. Example 10. All right. An organism's step angle is measured by is a measure of walking efficiency. The closer the step angle is to 180 degrees, the more efficiently the organism walked. So the diagram shows a set of footprints for a dinosaur. Find step angle B. Find measure of angle B. Okay, now this is side, side, side. So side, side, side is case 4. And in case 4, we have to find the largest angle first using the law of cosines. Now, luckily, the largest angle happens to be angle B. 3.2 meters is opposite angle B. That's the longest side. So angle B is the largest angle. So luckily, our first step is finding angle B, and that's the angle that we're looking for. So if we're looking for angle B, then we're going to do the law of cosines that has an angle B in it, and that's b squared equals a squared plus c squared minus 2ac cosine angle B. b squared is 3.2 squared equals a squared is 1.5 squared plus c squared is 2 squared, 4, minus 2 times 1.5 times 2 cosine angle B. All right, 3.2 squared. 3.2 squared, 10.24 equals 1.5 squared is 2.25 plus, what I wrote. Just thinking ahead. 2 squared is 4 minus 2 times 1.5 is 3 times 2 is 6 cosine angle B. So 10.24 minus 2.25 minus 4 is 3.99 equals negative 6 cosine angle B. Cosine angle B equals negative 3.99 divided by 6. But I want to know what cosine is, so I'm going to do inverse cosine. I'm going to know what angle B is. I'm going to do inverse cosine of both sides. Measure angle B, approximately equal to, so negative 3.99, so divided by 6 gets me a negative 0.665, and I got to do the inverse cosine of that, and I get 131.7 degrees. And that is the step angle for this particular dinosaur, 131.7 degrees. That was example 10. Here we have our chart. And example, I missed a page somewhere. Oh, I'm sorry, I didn't miss a page. Those are the examples of the ambiguous case of the Laurent signs. You can go through them if you want. I didn't print them. You can go through them, but you do not need to know them. So examples 11, 12, and 13 are the 3 different scenarios that can happen when you have the donkey theorem, the ambiguous case of the Laurent signs. Again, if you want to look at them, go right ahead. They're solved for you. Hopefully you can follow the way they're solved. But you do not need to recognize the ambiguous case of the Laurent signs, and you do not need to know the three different scenarios until you take trig and pre-calculus. All right, example 14, using the law of cosines, side, angle, side. And I'm not giving you a picture this time, but we have all the information that we need right here. So this is side, angle, side. Case number 3, side, angle, side. We find them, the third side using the law of cosines. Then we have to find the smaller of the 2 remaining angles. So third side using the law of cosines. So what side's missing? We know B, we know C, we're missing little a. So a squared equals b squared plus c squared minus 2bc cosine angle A. Plug in everything that we know, which is most. A squared equals 13 squared plus 15 squared minus 2 times 13 times 15 cosine of 43 degrees. A squared equals 169 plus 225 minus 26 times 15, or 30 times 13 390 cosine 43 degrees. Now, I'll square root that. A equals, we're going to square root both sides. We're looking for A, not A squared. 169 plus 225. 169 plus 225. 394. Square root 394 minus 390 cosine 43 degrees. Notice I did not do 394 minus 390. Don't make that mistake. That's an equals for now. Here it's the approximate. All right, go to our calculators. 43 cosine of 43 degrees times 390. And we're going to subtract that from 394. I've got a number that's like 108.772, so on and so forth, and I got to do the square root of that. So little a is approximately 10.4 meters. So we have found the third side. Now we have to go for the smaller of the two remaining angles. So the two remaining angles are B and C. The smaller of the two remaining angles is angle B. So using law of sines, sine angle B over 13 equals sine of angle A, which is 43 degrees, over little a we just found 10.4. Multiply both sides by 13. Sine angle B equals 13 sine 43 degrees over 10.4. Do the inverse sine of both sides. And we're going to get measure of angle B approximately equal to 13 times sine of 43 degrees divided by 10.4 gives me a 0.85249, so on and so forth. And we're going to do inverse sine of that, and we get 58.5 degrees. So there's the measure of angle B. Measure of angle C is going to be subtracted from 180. So 180 minus 43 minus 58.5 equals 78.5 degrees. So measure of angle C, 78.5 degrees. Example 15, law of cosines, side, side, side. So we know A, B, C. This is case 4. Case 4, side, side, side. You have to go for the largest angle using the law of cosines first. After that, it doesn't matter. All right. So we know little a is 9, little b is 16, little c is 21. Little c is the biggest, so angle C is the one that we're going for. C squared equals a squared plus b squared minus 2ab cosine angle C. 21 squared equals 9 squared plus 16 squared minus 2 times 9 times 16 cosine angle C. 21 squared, 441, equals 81 plus 256 minus 18 times 16. 18 times 16, 288. Cosine angle C. Again, don't combine these two. It's 441 minus 88. 441 minus 81 minus 256. 104 equals negative 288 cosine angle C, divided by negative 288. Cosine angle C equals 104 over 288 negative. Inverse cosine both sides. Measure of angle C approximately equal to 104 divided by 288 equals, I get like negative 0.3611111. I want to do inverse cosine of that. I get approximately equal to 111.2 degrees. So this is the measure of angle C. At this point, I can go for angle A or angle B next. Doesn't matter which one. I'm going to be using law of sines. Slide over here, and I'm going to use law of sines over here. I'll go for angle A first. Sine angle A over little a, 9, equals sine of angle C, 111.2, 111.2 degrees, over little c, which is 21. Multiply both sides by 9. Sine angle A equals 9. Sine 111.2 degrees over 21. Inverse sine of both sides. Cancel, cancel. Measure of angle A equals, now we go to our calculators. 9 times sine of 111.2 divided by 21. I got 0.399567, so on and so forth. Inverse sine of that, and I get approximately equal to 23.6 degrees. Got angle C, I have angle A, I need angle B. By subtracting from 180, 180 minus 111.2 minus 23.6 gets me 45.2 degrees. There's my 3 missing pieces for example 15. And example 16. Surveyors, often confronted with obstacles such as trees when measuring boundary of a lot, one technique used is to obtain an accurate measurement is the so-called triangulation method. In this technique, a triangle is constructed around the obstacle and one angle of the two sides of the triangle are measured. Use this technique to find the length of the property line, the straight line between the two markers. So we know this is 18 feet, we know this is 14 feet. This is a marker here, this is a marker here. What we don't know is from here to here. Like I said, we know that we've got, what, 32 feet so far. We need this dotted line here, this missing piece of the triangle to find. Okay, well, what do we have? We have side, angle, side. When we have side, angle, side, it's case 3. Find the third side using the law of cosines. Okay, so I'm going to call this angle C, and I'll call this little c, just for writing out the formula. Okay, because I'm looking for the little c. This will be A, this will be B. little a, little b. Okay. So c squared equals, some space here, equals a squared plus b squared minus 2ab cosine c, angle c. C squared equals 14.0 squared plus 13.0 squared minus 2 times 14.0 times 13.0 times cosine of 70 degrees. Calculator. C squared equals 14 squared, 196, plus 169, minus 28 times 13. 28 times 13, 364 cosine 70 degrees. So c squared equals 196 plus 169 is 365 minus 364 cosine 70 degrees. Yet again, do not make the mistake of doing this subtraction. Square root both sides. C approximately equal to 365 minus 364 times cosine of 70 degrees. I get approximately 240.5. I got to square root that. So approximately 15.5 feet. So the final answer, property line, length of the property line, length length of property line equals 15.5 plus 18.0 plus 14.0 gives me 47.5 feet. Using the law of cosines, a little bit of surveying. Okay. That's the end. Thank you very much. Bye.